we will we'll get to your questions, but I'm not ignoring you. Just if I sit there and try to read everyone's chats as they go by, this presentation will grind to a halt because I can't. I'm kind of old. I can't do too many things at one time. Uh-oh, I clicked on the wrong button here. Oh no! Stand by. Technical error. All right, so here we go. Boop, boop, boop. All right, so thumbs up if you can see severe weather talk. All right, very good. Thank you. Thank you. Right here. I love it when technology works. All right. So I did mention that I work for the National Weather Service. If you saw this yesterday, because I gave a talk on the weather basics yesterday, if you saw this part of the presentation, just sit back, relax, because I do like to talk about my job. A lot of people are interested in my job. I am part of the National Weather Service. There's all these local offices in the National Weather Service. It's a very local-driven kind of government agency. There's over 120 weather offices all across the United States. This map represents each of those colors on the map represents a different weather office. Let me turn on my laser. Each weather office kind of focuses in on its own area of responsibility. So here's Amarillo's area of responsibility is the northern part of the Texas Panhandle and the Oklahoma Panhandle. I mentioned I'm in the El Paso area, but here's a little secret. The office is actually in Santa Teresa, New Mexico. So our office covers just a little bit of far west Texas and a big hunk of southern New Mexico. For I think a lot of you all are up in Albuquerque. You can see Albuquerque, the National Weather Service office in Albuquerque. They cover a big hunk of the northern 2/3 of New Mexico, and Midland, Texas actually grabs the southeast corner of New Mexico, and they grab Eddy and Lee County down there in New Mexico. So there's 3 National Weather Service offices that cover New Mexico. Like I said, each of these weather offices focuses in on its own area of responsibility, and we become the subject matter weather experts for that area. And we issue the warnings. If you've ever been at home at night, mom or dad's cell phones made that noise, or your cell phones made that noise, or you've seen the weather words scroll across the television screen, it's the men and women working in the Albuquerque, Midland, and El Paso offices that are issuing those warnings to let you know when the bad weather is coming to town. Because that's the mission of the National Weather Service, is to protect lives and property and to help people stay safe from the weather. Now, each of these offices, in addition to the warnings, also issues weather forecasts. Now, a weather forecast is simply a guess or a prediction of what the weather is sometime into the future, whether that future is 5 minutes from now or whether that future is 7 days from now, because we issue several different kinds of weather forecasts. One type of weather forecast is for pilots, for the pilots that are flying into the Sunport, Albuquerque Sunport, or the El Paso International Airport. But we also issue forecasts for pilots flying into the smaller airports, like for Roswell or Tucumcari or Deming or Las Cruces. We also issue forecasts for people who fight the forest fires up in the mountains. We issue forecasts for boaters who are on the lakes of and the rivers of New Mexico, like the Rio Grande or the Elephant Butte River. I'm sorry, the Elephant Butte Lake. We also issue forecasts for people like me and you, and that includes things that are real, that help us make decisions, like is it going to be hot, is it going to be cold, is it going to be rainy or dry, windy or calm, so that you can decide, if you're going out, do I need to wear a jacket? If I'm going to the store, do I need to take an umbrella with me? Or if I'm going to go out and play, do I need to wear shorts? Again, the mission of the National Weather Service is to protect lives and property from the weather and to help people make wise weather decisions. All right. So we're going to talk about several different kinds of severe and extreme weather. And almost always, not always, but most of the time, the severe and extreme weather, it starts off with thunderstorms. And we didn't get a whole lot of thunderstorms this year through our monsoon season. I know at least down south, southern part of New Mexico, we didn't. It was a very disappointing monsoon season. But thunderstorms is where we get a lot of our severe and extreme weather. So I thought I would take a few minutes to talk about what it takes to get us a thunderstorm, because it takes several weather ingredients to get a thunderstorm. Now, here's another map of the United States, but this map shows the number of days a location has hears or sees a thunderstorm. So your eye's kind of drawn to the middle part of the country here, like Oklahoma, Kansas, Missouri, and Arkansas, where they get thunderstorms 50 to 60 days out of the year. You can see there's actually a little maximum here in northeastern New Mexico. That's due to the topography there. But look at this, out on the west coast Wow, they only get thunderstorms 10 days out of the year. So out of 365 days out of the year, they only get thunderstorms 10 days out of the year. But holy moly, look at this. Down here in Florida, they're the thunderstorm capital of the United States. Parts of Florida get over 100 days of thunderstorms each year. That means every third day they get a thunderstorm down there. So, and the reason for that is that they're a peninsula, so they stick out between three, they have water on three sides of them, and they're sticking out into between the warm waters of the Gulf of Mexico and the warm waters of the Atlantic Ocean over here. And you'll see why those warm waters are real important here in a second. All right, so let me ask you a very important question. How many of you all have asked, or how many of you have helped mom or dad bake a cake? Anybody? Thumbs up? Oh yeah, lots of hands. You know why? Because we all like cake. I love cake, let me tell you. I love cake, and that's why I like to make it. So, but when you're making that cake, you're mixing all of the ingredients up. You're mixing. But as you're mixing in the ingredients, you're putting in like the flour and the baking powder and maybe some sugar and maybe some water. You're mixing it all together. But as you're mixing it up, you forget to put in the eggs. You keep mixing it up. You pour that batter into the pan, and you put the pan in the oven. Now, do you guys think you're going to have a nice fluffy cake come out on the other side of that oven? No. You know why? Because you left out one of the ingredients. You're going to have something come out of the other side of the oven, but it certainly won't be a nice fluffy cake. And the same thing happens in the weather. When we're trying to get a thunderstorm, all the weather ingredients have to come together just right for us to get a thunderstorm. We might get a cloud, we might get a shower, or we might get a rain shower if some of the ingredients aren't right. But all the ingredients have to come together just right. And those three ingredients include moisture, a lifting mechanism, and instability. I want to talk about each of these real quickly right now. So moisture, you guys have probably gone over the three states of matter. If you haven't, they're easy: solid, liquid, and gas. So the three states of matter are solid, liquid, and gas. And moisture, or that's just another name for water, is actually one of the unique molecules because it can exist in all three states of matter in the atmosphere at the same time. You guys are all familiar with liquid water. You take a bath in it, you drink it. During the summer, we swim in it. There's lakes and rivers near us full of it. You guys are also probably familiar with moisture in the solid form. You get ice out of the freezer. That's frozen water. If you ever go up into the mountains during the wintertime, or maybe even down in the lowlands, we get snow. Snow is another form of solid water. You may not be as familiar with water in the gaseous form, or what we call water vapor. Believe it or not, right now, floating around in your house is water vapor. Now, don't look around for it. You can't see it. It's invisible, just like the oxygen and the nitrogen in the air. But that water vapor in the air is very important. And that's what helps fuels our clouds and eventually our thunderstorms. So if you don't have water vapor in the air, if you don't have moisture in the air, you're not going to get clouds. When you're watching the news, you may hear the people on the weather talking about the humidity or the dew point. Those are just measures of the amount of moisture in the air. And that's why we measure it, because it's very important. Now, the second thing we need is a lifting mechanism. And that lifting mechanism, I'm not talking like a crane or something like that. I'm talking about a weather ingredient that lifts the air in a very broad kind of way. And we do that a couple of ways. One way is with a cold front. If you've ever looked at a weather map, you've seen a red line, that's a warm front, and a blue line, that's a cold front. It's got some blue arrows on it. That cold front acts like a bulldozer or a wedge. And as it moves through the atmosphere, it's actually pushing up the air right out in front of it. So you can get some right along that cold front. You can get some lifting motion right along that front edge of that cold front. And you can really get some good thunderstorms right along that cold front. The other way we lift the atmosphere in a very broad kind of way is with an area of low pressure. Again, if you looked at a weather map, you've seen the H's and the L's on there. The H's stand for high pressure, which usually gives us happy weather, and the L's stand for low pressure, which usually gives us lousy weather. These areas of low pressure, all the air is rushing into them, and we get that lift because all that air gets squished and lifted up into the atmosphere. So once you get that lifting motion, again, when you get that lifting motion, we can get some very interesting weather. And you know what? Since I'm talking to you guys, like I said, I teach this to kids all over the United States, and a lot of times I'm teaching to kids out on the East Coast. I don't usually mention mountains, but mountains, since we have mountains, we got lots of mountains in New Mexico, that is actually a third way that we lift the atmosphere in a broad kind of way. As the air flows up and over the mountains, we can get clouds forming. And if you ever, on the monsoon days, if you'll notice, many times the thunderstorms form first over the mountains, again, because we lift that air over those mountains. So once you got moisture and once you got a lifting mechanism, you need instability. And instability is just a big fancy science word that means when you lift something up, it keeps on going up. Let me ask you guys, if you guys take a rock and throw it up into the air, does the rock keep going up or fall back down to the ground?
It falls back down to the ground.
Exactly, it falls back down to the ground because that rock is heavier than the air. And that rock, and remember, if you unmute yourself, you got to mute yourself back. So that rock is what we call stable, and that rock is compared to the air because it's heavier than the air around us. And what happens is that that rock will fall back down to the ground. Now, let's say you have a balloon. It's one of those balloons that's floating at the end of a string. You get it like at the fair or at a birthday party. If you let that balloon go, does it keep going up or does it fall back down to the ground?
Keep going up.
It keeps going up. Exactly. And then you, your brother and sister go, yeah, my balloon just floated away. Well, that balloon is lighter than the air around it. You can say it's unstable compared to the air. Sometimes when we lift the atmosphere, it's heavier than the air around it and it sinks back down to the ground. Other times when we lift up the atmosphere, it's lighter than the air around it and it keeps going up. Now, I know that's kind of a concept that's kind of hard to picture in your head, so I've got a video. So I'm going to show you this video that kind of demonstrates what this looks like. So this is a time lapse of thunderstorms forming over the mountains during the afternoon. And it looks like it's going to, there we go. You can see we've got moisture in the air because we can see the clouds bubbling up. You can also see there's something lifting. We got that lifting mechanism because they bubble up. But look at this, they bubble up and then they sink back down. They bubble up and then they sink back down. That's because the atmosphere is very stable. But one of the things that destabilizes the atmosphere is heat. As the afternoon gets hotter and hotter and hotter, we're going to see more and more clouds form. And just like a hot air balloon, if you've ever seen one of those, when they turn on that burner, the balloon floats up. Well, the same thing happens. As it gets hotter and hotter, these cloud elements get higher and higher until one of them can eventually bust on through, and there it goes right there. And now we've got all the cloud elements moving up. Now the atmosphere is unstable, and we've got moisture, we've got lift, and now we've got instability because now we've got a very mature thunderstorm. And once we've got a very mature thunderstorm up and going, then we can get all kinds of severe and extreme weather. Dr. Allison, did we have any questions before we jump into? So let's answer a couple questions before we jump into lightning.
All right. So one is, can a water spout freeze?
I don't think so. You know, what can happen is that, and actually it did happen in New Mexico. We had a rare tornado when there was snow on the ground, and it pulled a lot of that snow up. And that happened either last winter or the winter before, because no one had really ever seen a tornado with snow. Remember, to get a thunderstorm, you need that lifting. You need warm, moist air kind of lifting. And believe me, during the winter with snow on the ground, that's not really the best environment to get a thunderstorm up and going. So to see a tornado with snow on the ground was very unusual. But actually, to like freeze a cyclone like that, a water cycle there, a water spout, it's just not ever going to get that cold that fast.
Lily has a great question. What would happen if we didn't have weather?
If we didn't have weather, I wouldn't have a job. I think, so what happens is that weather is just the atmosphere always trying to get into balance. You guys know that the North and South poles are very cold. and that the equator is very, very warm. And the way the Earth is set up, that the middle part of the Earth would continue to get warmer and warmer and warmer, and the poles would continue to get colder and colder and colder. But what we do is we're always transferring, we're basically pulling the cold air down from the poles, and we're pushing the warm air away from the equator to try to keep things balanced. It never gets balanced, but like during the winter when we get those cold fronts coming down, a hurricane is just a big heat engine that's moving a lot of heat energy up from the equator up towards the poles. So all of this weather that we do have is trying to help the Earth stay in balance. So if we didn't have that, I think the Earth would be a kind of a wacky place. We would not, parts of it would be getting colder and colder and colder, and other parts of it would be getting hotter and hotter and hotter.
Nice. Justin is wondering, what is the largest rainstorm that you know of?
So, it's kind of hard to put it into perspective because, you got hurricanes. That's a large organized rainstorm, and they can actually be the size of a state and dump just tremendous amounts of rainfall. But then you have like a monsoon season like we see in New Mexico, and it's not just one rainstorm, but it's over 3 months. We have that seasonal shift in the winds, and we get day after day of thunderstorms during a regular monsoon season. So the monsoon season, we get those. There's places in India they get like over 300 inches of rain a year. There's places in Hawaii are really rain prone. So there's places like that. So and that's one of the neat things about the United States is that there's parts of the United States that are very dry. Parts of the United States, like in Florida, they get a lot of rain. There's parts of the United States that get a lot of snow. So it's the challenge of people at these different weather offices to keep track of all those different kinds of weather.
300 inches of rain, that's 25 feet.
Whew, that's crazy. That is a lot of rain.
So Ava was asking about is there a famous tornado? And several students responded with the Joplin, Missouri tornado. So
Joplin was just in recent memory. I did glance down. I saw someone typed in the tri-state tornado. That is another famous tornado. It's actually the tornado with the most, I believe, the most fatalities associated with it because it was over 600 fatalities. It was back in the 1920s, traveled from southeastern Missouri across southern Illinois and into southern Indiana. That's why they call it the tri-state tornado. You have the Joplin tornado. Unfortunately, I guess we don't usually name tornadoes. If your tornado kind of gets attached with a name, that usually means something bad happened with it. So you have the Tuscaloosa tornado, you have the Joplin tornado, you have the El Reno tornado. Unfortunately, Moore, Oklahoma's had actually several very large tornadoes. Now, by far, the vast majority of tornadoes that form in the United States are the weaker tornadoes, and we're going to talk about that here in just a minute, are the weaker tornadoes. Particularly in New Mexico, we don't get a lot of tornadoes, but we do get some, but they're almost always those weaker variety of tornadoes. So, nice. But I have a lot more to talk about tornadoes. How about we do one more question, and then we'll get into lightning.
So let's do one more question, and it's not really a question, just a comment. Luke is making a connection between a cloud and a balloon, especially like a helium balloon.
Yeah, so like I said, in the hot air balloons, I think most of you guys, especially you guys there in Albuquerque, you've seen all the hot air balloons during the Fiesta. They turn on a burner, they make that inside that balloon envelope, they make it warmer than the air around it, and that floats that. It's amazing if you think about it. It floats that balloon up. The same thing happens in the atmosphere. We're warming up the air so that it's actually warmer than the air around it, and it keeps floating up. But as it floats up, it does cool down. Now, as you go higher in the atmosphere, it gets colder. And as you get colder, that water vapor condenses from a gas to a liquid. And that liquid and when I'm saying liquid, I'm not like talking like a bathtub of water up there. I'm talking about a tiny little droplet, and we call that a cloud droplet. And you could put like hundreds of them on the head of a pin kind of thing. But when you start to multiply them out, that's what makes that cloud. That cloud is tiny little water droplets. And then they keep lifting up. And eventually they get that flat top because they hit kind of what we call the top of the troposphere. That's the lower part of the atmosphere. And the top of the troposphere, the temperature starts to go up again, and that makes it very stable. So the cloud stops right there, and that's why you get the flat top on top of those thunderstorms. All right, so let's talk about lightning. Oh, now before we get too much into lightning, one thing I do want to talk about real quickly is that unfortunately weather can hurt people. I do not want you to come away from this presentation worried or concerned about, oh no, the tornado is going to get me or the lightning. I'm going to go over several safety tips associated with each of these kind of severe and extreme weather. If you follow the safety tips, you'll be safe more than likely from the weather. You know, you do have to respect the fact that the weather can hurt people. You know, it's like when you were playing maybe a game of ball with your friend next to the street. If your ball rolled into the street, you didn't just run into the street to get the ball. You respected the fact that the cars, if they hit you, can hurt you. So what you would do, you would wait, you would look both ways, no cars, you'd go out there, get your ball, and you'd come back. We have to do the same thing with the weather. You have to respect the fact that the weather can hurt people, but if you follow the rules, more than likely you will be safe. All right, so let's talk about lightning. I love lightning. Here's a great shot that one of my coworkers took of some lightning in Columbus, New Mexico, just last year. All right, so, oh, another video. I love videos, let me tell you. So instead of a time lapse, this is a super duper slow-mo of lightning. Just like, you know, slow motion, like in pro football or baseball or anything like that. So this is what a lightning looks like as it starts out from the cloud. Now, we can't usually see this part of the lightning. It's going too fast for our eyes and it's too dim. But eventually one of these little fingers touches the ground, and then that's what we see is that bright flash. That's what we see as the lightning strike. So let me try this again. Let me back up the video. So each of these little fingers are called step leaders or dart leaders. They're looking for the fastest, most efficient way down to the ground. Just like a runner in the race, just whichever runner crosses the finish line first is the winner of the race. Whichever one of these little step leaders makes a connection with the ground, that's what makes that big bright flash that you see with your eyes. Now, that lightning is super duper hot. It's actually 5 times hotter than the surface of the sun. So you wouldn't want it to touch you. But when you heat up the air that's right around that lightning channel, when it heats up, when you heat up something, it usually gets bigger, it expands. And that air, as it expands, that means it just gets bigger and it spreads out, and then that bumps into other air molecules, and those air molecules bump into air molecules, and eventually those air molecules bump into our ears, and that's what we hear as thunder. So it's the heat of the lightning that we see that actually makes the thunder that we hear with our ears. That's why it's not uncommon for you to see lightning and then several seconds later hear the thunder. Because first of all, light travels faster than sound, but also because it's the light, the heat and the light of the lightning that makes the thunders that we hear. All right, so here's some lightning facts. All thunderstorms produce lightning, and unfortunately, it can be deadly. Each year in the United States, more than 400 people are struck by lightning, and sadly, 50 of those people on average die each year. There is no safe place outdoors during a thunderstorm. Lightning can actually reach 15 miles out ahead of the thunderstorm, and it can actually reach 15 miles out behind the thunderstorm. So even after the thunderstorm has gone by you, it can actually reach 15 miles out behind you. So we have a saying in the National Weather Service, when thunder roars, go indoors. And it's just a rhyme that helps you remember that when you hear thunder, it's time to head inside, because going inside is where you're safe. Now, I like to show this picture because this picture demonstrates what happens when lightning hits the ground, and in particular, the green of a golf course, you know, where they play golf and they put the ball around. You can see right where the lightning struck, right here in the kind of top part of the screen. But you can see how for tens of feet in every direction, how the heat and the electricity spread out in all directions. So you don't have to be standing right where the lightning strikes the ground for it to affect you. You can be way off to one side, and that electricity and that heat can actually travel through the ground and still come up through the ground and get you. And if you're in water, that's even worse, because water conducts electricity very well. So you don't, that's why we just say it's not safe outdoors. It's time to go inside when you hear thunder. So here are some safety tips. If you're outdoors, you want to avoid water. So get out of the swimming pool, get out of the lake, get out of the river. You want to, if you're out hiking or, you know, on high ground or in open spaces, when you hear thunder, it's time to head back down towards home base. You want to avoid tall objects like trees or, you know, telephone poles, flag poles, or metal objects, kind of like a flagpole that's sticking up. You don't want to shelter. A lot of the parks have those picnic shelters. They have a roof on them, but they don't have any sides or any walls. That's not a good place to shelter from lightning, and certainly not under a tree. Let me tell you, people say, you know, oh, during a thunderstorm, it started to rain. I didn't want to get my hair wet, so I wanted to go, I ran under a tree to be safe from it. So I tell people that's not a good place to be. Under a tree is not good because that tree sticks way up. And what happens, the lightning actually would strike the tree, then work its way down, all the way down to the tree, and then it spreads out through the root system. And if you're standing on under the tree, you're standing right over the roots. And then that electricity can actually work its way up out of the ground and get you that way. So we tell people the best place is to go inside a building or actually a metal vehicle like a car or a truck. It's got to be an all-metal vehicle. So I'm not talking about like a convertible. You want a car or a truck. And that's actually a safe place to be because that car, that truck, the way the metal and electricity behaves, if you're inside this metal box, and that's essentially what a car or a truck is, you're safe because electricity stays on the outside of that metal box. It's called, actually, if you want to look it up, it's called the Faraday cage. And what happens is that electricity stays on the outside of a metal box if you're inside of it, you're actually safe. The electricity doesn't come in there. That's why it's actually safe in a car or a truck during a thunderstorm. But by far, the best place to be is inside of a house or a building, you know, school, a church, mall, anything like that, a store. But when we get you in, when you get inside, we tell people we want to have some safety tips inside because if the lightning strikes the top of the building, that electricity, that lightning wants to go from the top of the building down to the ground the most efficient way it can. And the two ways that it does that is going through the electrical system or through the pipes or the plumbing. So you don't want to be doing anything associated with the plumbing of the building. So you don't want to be washing any dishes, taking a bath or a shower or anything like that during a thunderstorm. The other thing is you don't want to be doing anything that's using the electrical system, you know, that's plugged into the wall. So you don't want to be playing PS4 or Xbox or something like that. You don't want to be on like a computer that's plugged in. Now, if you've got like a tablet or a cell phone that's not charging, that you're just standalone, that's okay, something to do. But if you're charging your tablet or you're charging your phone, you don't want to be, because that's hooked into the electrical system now. So what I tell people, the best thing to do when thunder roars, go indoors. And when you go indoors, read a book. I know, it's a crazy concept, reading a book. It's crazy, but it's actually the safest thing to do inside. So people will ask, well, how long do I have to stay inside? And I tell people what you do is you hear thunder. When thunder roars, go indoors. And you look at the clock. When you hear thunder, look at the clock. It's got to go 30 minutes when you haven't heard thunder anymore. And then it's safe to go back out. So if you're inside and you hear thunder and you start the clock, and 20 minutes later, you hear thunder again, you got to start the clock over again until you go 30 minutes without hearing thunder. So when thunder roars, go indoors and then wait 30 minutes until you haven't heard thunder anymore. Then it's safe to go back outside. All right. So, Dr. Allison, do we have any other questions?
Nope. The kids haven't been using the chat appropriately, so we don't have any questions at this time.
No problem. Then we'll roll on and we will head into tornadoes. Now, I usually like to ask, do we get tornadoes in New Mexico? And I'm pretty sure the answer would, a lot of students would actually say, no, we don't. But here's a picture from Flower Mound, New Mexico, just a couple years ago, that we do get tornadoes. So the better question is, do we get a lot of tornadoes in New Mexico? And that's the better question because, of course, the answer is no. We don't get a lot of tornadoes, but we certainly do get tornadoes in New Mexico on occasion. All right. Now, a place that they do get tornadoes is in Oklahoma. So I thought I'd show you this video of one tornado that happened about 4 years ago in Oklahoma. Let me jump ahead here. So you can see what it looks like. And this is actually a pretty strong tornado. I forget if it was a F3 or an F4 tornado, but we'll talk about that here in a minute. But you can see this tornado, the video slowed down or kind of settled down here. This video shows you a tornado as it's going through some farmland. So you'll see some black dots fly by. That's some crops. That's parts of tree limbs and things as they're going by. So this tornado has very violent rotation. But as they zoom out, unfortunately, it's going to come to the barn and the house of this farm. And now you're going to see all kinds of debris in the air. You're going to see shingles, parts of the insulation, the roof are all flying around. So you've got this really tight circulation. Now, as you look down the road here, you might see a flash down the road. That's the winds of the tornado pulling down the electrical wires. Now it's pulling up like whole telephone poles, whole trees, very violent rotation right where that tornado is touching the ground. So you can see, and now, even now, a few minutes later, you can still see some debris flying around that tornado. So that tornado is just an amazing, very concentrated wind, because they have some of the strongest winds in the earth in that rotation. All right, so this map shows you where tornadoes are most likely to form. And of course, your eye is immediately drawn here to North Texas, central Oklahoma, and southern Kansas, even up into Nebraska and South Dakota. That's what we call Tornado Alley. And that's where we're most likely to see tornadoes. Now, if you're looking at this map, it may look like they don't get any tornadoes out here in western New Mexico or Arizona. They don't get enough to get kind of colored on this map. You see that gray color is fewer than one. And that's per 10,000 square miles. On average, you know, where I work, we usually get one tornado a year. Because believe me, California gets about 11 tornadoes a year. Oregon and Washington, they usually get 2 or 3 tornadoes. So every state of the United States has seen tornadoes. They're just most likely to occur here in the middle part of the country. And I'll show you why that is. That's where we call Tornado Alley. You remember how we talked about the weather ingredients to get a thunderstorm? Well, the weather ingredients, that's, you know, when we're using those weather ingredients to make a cake, you know, the ingredients to make a cake are kind of similar to the ingredients to make a thunderstorm. Well, to make a tornado, imagine that's like a fancy cake. You even have to have more ingredients put together to get a tornado. Some of those ingredients include warm, moist air, usually out of the Gulf of Mexico. Actually, higher up in the atmosphere, you need some warm, dry air coming in from the desert Southwest from New Mexico. You need some cold, dry air coming on the backside of the system out of Montana and Wyoming. And we need the jet stream. The jet stream, I don't know if you guys know this, but the air above us is always flowing along in this river. It's this river of air. If you've ever gone out like on a summer day and you've seen those white puffy clouds, if you stand there long enough, you'll sit there and go, hey, they're moving. These white puffy clouds are actually floating along in this river of air. And sometimes this river of air has parts of that river that actually move faster than the other parts. And we call that the jet stream. And that jet stream gives you a little extra spin, a little extra energy in the atmosphere. And all these weather ingredients all come together most often in the middle part of the country, from Texas to Oklahoma to Kansas. But you know what? Sometimes they can come together in other parts of the country. And like I said, every state of the United States has seen tornadoes at one time or another, but they most likely occur here in the middle part of the country. All right, I've mentioned this a couple times, so I wanted to go over it real quickly. It's how we rate tornadoes. We rate them on what's called the Enhanced-Fujita scale, and it goes from a 0 to a 5. And it's named after Dr. Ted Fujita. He did pioneering research in tornadoes and microbursts from the University of Chicago. And I think there's a very interesting documentary on him on PBS, if you wanted to look that up. But he's a fascinating character that came up with this as he was doing this tornado research. But what happens is that when there's a tornado going on, you wouldn't want to send some poor person out there with a wind measuring tool and say, go stand next to that tornado and see how fast the winds are blowing, because that just wouldn't be safe or practical. So what happens after a tornado happens, the National Weather Service sends out what's called a survey team, and this survey team goes out and they look at the damage that the tornado did to determine, based on the damage, how strong the winds were, and to give it a EF scale rating. And like I said, that scale rating goes from a 0 up to a 5, with 5 being the strongest. So if the EF 0, that's our weakest tornadoes, it has winds of 65 to 85 miles an hour. That's a little faster than mom or dad drives on the interstate. And then, like I said, as the wind speeds get higher, the EF scale gets higher, and you start to get worse and worse damage. When you're talking about EF3 and EF4 damage, you're talking about major damage. And with the EF5 tornadoes, that's a kind of tornado that actually can take a well-built home and completely push it off and destroy it off its foundation, so that when you see the damage from it, it's actually just this concrete slab. It can actually pull up asphalt from the street as well. So these EF5 tornadoes have the strongest winds in them. Now, the good news is these EF4 and EF5 tornadoes are very rare. Matter of fact, it's been several years since we've had an EF5 tornado. I think we've had 1 or 2 EF4 tornadoes this year, and I know we had one last year, but I'm pretty sure it's been several years since we've had a EF5 tornado. By far,
has there ever been an EF6?
No, the EF scale just goes off, and I saw someone reference that. The EF scale, if it's 200 miles an hour or more, so the EF scale just kind of goes higher. You can get faster wind speeds, but it would still just be called an EF5 tornado. But by far the majority of the tornadoes are these EF0, 1, and 2 tornadoes with the lower end. 90% of the tornadoes are these weaker tornadoes, and almost the vast majority, almost all the tornadoes we see in New Mexico are these weaker tornadoes. So here's some tornado safety tips, just in case you did happen to see one. If you're out in the open rural areas and you can see the tornado is far, far away, you can get in a car or a truck and try to drive away from it. But so many times the problem out here is that there's clouds are low to the ground, there's some hills in the way or trees. If you can't see the tornado and you're under a tornado warning, don't get in your cars or trucks, because the tornadoes, even the weak ones, can pick up these cars and trucks and toss them around like they're toys. So if you're stuck outside, if you're playing soccer on one of those soccer fields that has 1,000 soccer fields, and there's just no way to get quickly to someplace safe, we tell people to get down in a ditch and get low. It's not really the winds of the tornado that hurt people so much. It's all that debris, all the insulation, shingles, tree limbs that are blowing around. So we tell people you want to get down in a ditch, get kind of low, so those tornado winds kind of blow over you with all that debris. But of course, the best place to get is inside. Inside is best by far. And you want to seek a room in the middle of your house. Now, for certain parts of the country, we tell the kids to get down in their basement. But I know for a lot of homes in New Mexico, we don't have basements. So what you need to do is talk to your mom and dad and ask them, where's a safe room in our house from tornadoes? And what you're looking for is a room in the middle of your house or your apartment that has as many outside walls, or has many walls between you and the outside. And you don't want any windows or skylights, because it's real easy for one of these tornadoes to get a 2x4 and to push that 2x4 through a wall or easily go through a window. So, you want as many walls between you and the outside. I grew up in Tulsa, Oklahoma, where we get tornadoes. And we had this walk-in closet right in the middle of our house. And when there was a tornado, it was me, my 2 brothers, my mom and my dad, and our dog, and we would just hunker down in this little closet with a radio until the tornado threat went by. So that's what you need, is a place like that in the middle of your apartment, in the middle of your house, down on the lowest floor, if as possible. You also want to be, like I said, stay away from windows. If you happen to live in a mobile home, and a lot of people do, they're just not safe during a tornado. They're very easily rolled onto their side, and they're not made to roll, of course. So when they roll, they fall apart, and then there's all of this debris that you would be stuck in. So we tell people you need to, when you're under a tornado warning, you need to get out of your mobile home. Now, a lot of mobile home parks have tornado shelters, community tornado shelters that you can get to and get in. If you don't have a community tornado shelter, ask mom or dad, where is a safe place to go very quickly if there's a tornado? Maybe that's a store across the street. Maybe it's a neighbor's house that's nearby, something like that, so you know where to go. Because being inside of a mobile home during a tornado just isn't a safe place. All right, so that wraps up tornadoes. And before we move on to the next subject, Dr. Allison, do we have any quick questions?
Yeah, just a few questions. You answered the question how tornadoes form, so that was a good question. Thank you for asking that. What about the difference between a dust devil and a tornado?
So I tell people that a dust devil is kind of like the cousin of the tornado. It's formed by a different process. If you've ever seen a tornado, usually what we do is we start a tornado up in the cloud. It's what's called a mesocyclone. So actually the thunderstorm itself is actually beginning to turn like a big top. And as that circulation tightens up, that tornado drops at the bottom and works its way down. Whereas a dust devil, you guys have probably seen them. They usually form on what kind of days? Hot, sunny days. They usually are not associated with a cloud. So you get a dust devil on a hot sunny day, and it actually starts at the ground and works its way up to the cloud, up into the sky. Now, believe me, I've seen dust devils can get pretty high up into the air, but most of the time they don't reach up to where the clouds are, if there are clouds at all. Usually you see them best if you're driving along on I-10 or I-25 and you look out and you see a dust devil out there in the desert. It's on a nice, hot, sunny day.
Nice. And you also answered the question how big a tornado can be, especially how powerful they can be. So one final question, the number of tornadoes in New Mexico.
So, good question. So I'm going to look up here because I have another presentation. I mentioned it yesterday. Let me pull it up here so I can get you the right number. On average, if I'm pulling up the right one, I hope I am. Like I said, the most likely place you're going to see tornadoes in New Mexico is out in the East Plains, Roswell, places like that. Out on the East Plains, away from the mountains and things like that. Now, a lot of people think the mountains prevent tornadoes. That's just not true. If your grandma or grandpa are telling you that, it's not true. But what happens is that we get the tornadoes out on the East Plains. Again, that's because that moisture is where all those weather ingredients are most likely to come together there in the East Plains. And I finally found my presentation I was looking for. On average, New Mexico gets each year 10 tornadoes. So nice. It's not zero, but it's certainly not like they see. Texas, just to the south, gets over 150 tornadoes. Now, part of that is because Texas is such a big state, but they get a lot more in Texas. Again, that's because all those weather ingredients are coming together just right. All right, so let's hop back in here. And now we're going to talk about our next extreme weather, if it'll pull up, and we're going to talk about flash floods. And here's a picture of Hatch, New Mexico. Let me turn this off. There we go. This is Hatch, New Mexico back in 2006 when they had a flood that covered almost the entire town of Hatch, New Mexico. So we do see flash flooding, especially during the monsoon season here in New Mexico. It's one of our bigger threats. Here's a video I'd like to show of a little town in Maryland. It's called Ellicott City. There's a little stream that runs through the middle of town, runs right next to Main Street. But unfortunately, this little town is at the bottom of kind of a valley. And on this day, and actually it's happened several times in Ellicott City, you can see it's very hard to tell where this river is and where Main Street is because there's so much water flowing through the middle of the town. And this town has actually been devastated 2 times by these massive flash floods. And look at this. It's actually pushing cars down the streets of Ellicott City. And that water is only, about 2 feet deep. That's actually pushing those cars along. So it's not like too deep because moving water can really push a car. And I certainly wouldn't want to open this door. Let me tell you, you can see that water is just lurking outside that door. So flash floods. Here's a picture of Rio Rancho when they had some flash floods back a couple of years ago. Wow. Less than 2 feet of water can actually float a car. So what happens is that you get this car. A lot of people will think, I'm safe in a car's nice and heavy. But guess what? A car's not a boat. So these cars, they float actually pretty easily, but not in a way that you can control them like you can a boat. People tend to want to try to drive through these flash floods, and they don't realize that the car can get flooded, it can get floating, and then once you're in these flood waters, you're at the mercy of the water, and you just don't want to be there. Cars can easily be swept off the roads. It really takes less than 6 inches of moving water to sweep you off your feet. So if you imagine you're kind of holding your index finger and your thumb out, that's about 6 inches. So moving water is actually very, very powerful, and people don't realize it. Most flash flood deaths occur in vehicles. And again, people think they're in a car. It's a nice heavy car or truck. I'm safe. So we have a saying in the National Weather Service, turn around, don't drown. And that just tells people to be safe from this threat. When you come to where the road is flooded, to turn around and go another way. Because like I said, so many flash flood deaths occur in cars. A lot of times they occur at night. People are driving around. They don't realize the water is covering the road and they drive into it. And a lot of times what we see in New Mexico is the flooding that's associated with our arroyos. So it can rain real heavy up in the mountains. And if you're playing in one of these dry arroyos, 2 or 3 hours later, all of a sudden, this wall of 3 or 4 feet of water comes rushing at you out this dry arroyo. So it may not have rained a drop where you are, but they got 2 inches of rain up in the mountains. And then that water works its way and can take several hours to work its way off. So always be aware of, if you're playing outside, where it's raining and where that water goes. You want to avoid those arroyos. So here's a flash flood safety tips. You don't want to walk across any like flooded roadways. Like I said, you don't even want to hike or stand near water. I've told too many stories, kids hear on the news, oh, there's flooding going on in such and such a arroyo or creek. So they want to run outside and see what does it look like, but they don't realize that the floodwaters have eroded away the arroyo bank, or they may be stepping on some slippery grass and they slip into the water. And you don't want to be in those flash floodwaters because that water is moving very quickly. It can sweep you away. It's full of debris like tree branches and trash and things like that. So you just don't want to even walk near these flash floods. You want to be patient. You want to wait for the water to go down. Like I said, turn around, don't drown. It's better if you come up to the road and you tell where the water's crossing the road, tell mom or dad, turn around, don't drown. It's better to be late to soccer practice or take a few extra minutes to get to the grocery store than to drive through that flooded roadway. It's just not safe. And if you happen to live in a low-lying area that has a tendency to flood, when you see there's heavy rain in the forecast, that might be time to go visit grandma's house or visit somebody else's house. But if you're at home when the floodwaters start to come up, we tell people the best thing to do is to seek higher ground, whether that's the second floor of your apartment building or your house, or if it's just maybe the hill out behind your house. It's better to get wet in the rain than to be caught in those floodwaters. And actually, this picture on the screen, this was a flood that just happened a month ago, I guess 2 or 3 months ago in July, there in Truth of Consequences, there in central New Mexico. So we had a lot of rain that fell right in right in there, 3 to 4 inches of rain right in T or C, and it caused some flooding there. So I think that wraps up the presentation. We didn't even get to talk about hail, which is just big balls of ice that come down from the skies. Now, most of the time the hail we get is pea-size, but if you get a strong thunderstorm, it can get really big. We didn't talk about blizzards. We can see that especially up in the higher terrain of New Mexico. Real strong winds, blowing snow, low visibilities. Haboobs is another type of dust storm that we get in New Mexico that we can see. That wind coming out of the thunderstorm creates these dust storms. Sometimes, especially in the East Plains, we might see an ice storm. That's where liquid rain falls from the sky, but there's a cold layer of air near the ground, and that liquid water freezes, and that ice starts to build up on everything, and it's real heavy, and it pulls down the trees, limbs, it pulls down the electrical lines. Fire weather we've seen. Fire weather here in New Mexico, you take mountains, you take dry conditions, and you take the winds moving the fire down through the valleys, and we've seen that happen. You guys have been seeing in the news, California, Oregon, and Washington, the wildfires there. Another thing, extreme heat. Our bodies want to stay a certain temperature. They don't want to get too hot, and they don't want to be too cold. So if you're in a place that has super duper hot weather day in and day out and night in and night out, and you don't have an air conditioner or your cooler's not working and you can't afford to run it, then that's real hard on our bodies. It can actually make us sick. And the opposite happens as well. On a real cold day with snow, it's fun to go outside and make a snowman, throw snowballs, and make snow angels, but it's equally fun to come inside and warm up in front of the fire with hot chocolate or anything like that, because if you're cold for too long, it's actually hard on your bodies as well. So those are all severe and types of weather. I didn't even mention hurricanes. We don't really usually get hurricanes in New Mexico, but there's lots of different kinds of severe and extreme weather, and I wanted to cover some of them real quickly.
All right. And I think that hurricanes, there were a lot of questions about hurricanes. It's been an incredibly active hurricane season this year.
Definitely.
So I think that that's a great something that's great to follow up with on your own is look up hurricanes and what causes them. Yes. I do want to get to one last question, and then Wyatt, can you put your question in the chat box, please? One last question, and this is from Thaddeus. And the question has to do, and it's a good question because what you've been talking about, all these weather systems are powered by energy.
Yes.
And Thaddeus' question is, what would happen if there wasn't any sunshine?
So if there wasn't any sunshine, and actually all the weather on the earth whether it's hot or cold weather, clouds or anything, it all starts with the sun. That sunlight is what heats up the earth, and that's what starts all of our weather. So without the sun, it would be much, much colder on the earth. Of course, it'd be too cold for even life to exist. So we have to have the sunlight. But like I said, that's part of the problem. The middle part of the earth gets too warm, the poles get too cold, and we're just trying to equalize those. And that's what gives us so much of our different kinds of weather across the world and across the United States.
Nice. And Wyatt, you have been so patient raising your hand. Go ahead with your question.
I had hail once. It was at my old house. It was an apartment. I lived in an attic, and now I live in a different house. And I got a dog here.
Nice.
Yeah.
So
Thank
yeah.
you so much for sharing. Go ahead.
So hail, you know, a lot of times the hail that we see in New Mexico is that little pea-sized hail. Who likes to eat peas for dinner? I don't. I tell you, I don't like them. But I see some people do. Very good for you. Ugh, I don't like them. But that's usually the size of hail that we get a lot of times, that little pea-sized hail. But every once in a while, if you get the stronger thunderstorms, and hail inside of a thunderstorm, imagine like a juggler. That juggler is juggling the balls, and as long as the balls are kind of small, the juggler can juggle a lot of them. But as they get bigger and bigger, it's harder to juggle more. The winds inside that thunderstorm, as long as they're strong enough to hold the hailstone up, it can get bigger and bigger. But once it gets to a certain size, just like a juggler, if you give a juggler a bowling ball, they're going to drop all their balls. If that hailstone gets big enough, the wind can't keep it up anymore, and it falls out. So if you got weak winds in the thunderstorm, you might get some pea-sized hail. But if you got really strong winds, you can get golf ball, even tennis or baseball-sized hail.
All right. And I want everybody just to show a huge amount of appreciation for our guest speaker today, Tim Bryce for the National Weather Service and NOAA.
Round of applause.
Thank you so much.
Yeah, thank you for coming.
I do want to draw your attention to the New Mexico Science Fiesta that's going on through Saturday. Please join us. You can find the complete listing of programs at the Science Fiesta website here. And please send us your feedback. I put the feedback form, and we would like that feedback for everything that you see. If you wouldn't mind filling out a feedback form for everything that you participate in, it just really helps us. Saturday, the expo starts at 10 o'clock. It goes all the way to 3. You can drop in. We're having to find a spot at Explora where we can blow a trash can 30 feet into the air without hurting anybody. So it's going to be dramatic. So please join us on Saturday for the Science Fiesta Expo. And please fill out the feedback form. And also a huge round of appreciation for all our hardworking teachers out there. Yeah, thank you. And then with that, I know that many of you have to go. Daniela, while people are leaving, go ahead and ask your question.
I might be able to go on Saturday because when my school has there's something to go places, we always go.
Nice. Catalina, go ahead.
Bye.
Bye, y'all.
Bye-bye, everybody.
I have a question.
Okay.
Where's the Science Fiesta located?
It's all online. So if you go to the website, it's all online. So it's all virtual this year. So
Okay.
you'll get the links to join. Lily, go ahead.
Is it on? Could it be like every year?
Usually we do the Science Fiesta in person. So usually you get to come, for example, down to the State Fairgrounds, Expo, New Mexico. But this year, because of COVID, we had to do it all online. Lily, go ahead.
I was wondering about the floods. I was wondering how big they could get.
So usually in New Mexico, we don't get really, really super big floods. Actually, one of the larger floods was that Hatch flood. You know, this was before your time, most of your times, was back in 2006, we had widespread flooding all across New Mexico. Alamogordo had flooding, Hatch had flooding, El Paso had flooding, Las Cruces had flooding, Albuquerque had flooding. It was just a weather environment that had, but it's not like, the Rio Grande can flood a little, the Gila River can flood a little, but on average, we don't get the really big floods that maybe you see in the East Coast, like around Houston when they have a tropical system making landfall, or in Louisiana. But we can still get the flash floods that are moving through the arroyos and things like that. So it's just a matter of being safe and knowing where the rain is and where you are compared to it.
And then I'm going to say your name wrong. Is it Ayla? Ayla?
Okay, bye.
Bye-bye, Lily.
Bye,
It's
Lily.
Ayla.
Ayla, go ahead.
I think I might be able to come, but I'm going to my cousin's, so it might be a little bit noisy.
Okay. You can just join. It'll be great to see you there. All right. Bye, y'all.
Bye-bye.
All right.